Sure, Herb, here are the 6 core web vitals, followed by clear explanations written only with alphabetic characters, no numbers, symbols, or code. 1. Largest contentful paint. This measures how quickly the largest visible element appears on the screen. It reflects loading performance and helps show when the main content becomes visible to the visitor. A fast paint time gives a smooth first impression and keeps people from leaving early. 2. First input delay. This measures how long the browser takes to respond when a visitor first interacts with the page. It could be a click, tap, or key press. It represents responsiveness. Lower delay means the site feels immediate and reactive instead of frozen or lagging. 3. Cumulative layout shift. This measures how much visible content moves around while loading. A low shift means the page is stable. When layout jumps occur, buttons and images move unexpectedly and can cause misclicks or a poor experience. This vital focuses on visual stability. 4. Interaction to next paint. This is a newer measure that expands on input delay. It tracks how quickly the page reacts to any interaction and updates the screen. It shows how fluid the experience feels during ongoing use rather than only at the first click. 5. First contentful paint. This measures how soon any content, such as text or image, appears after the visitor opens the page. It is an early loading indicator that tells whether the page is showing something meaningful instead of staying blank. 6. Time to first byte. This measures the time from a request to the moment the browser starts receiving data from the server. It reflects server speed, hosting quality, and caching efficiency. Faster response means better performance for every other metric. Would you like me to connect each of these 6 vitals to the 6 pillars: security, access control, performance, reliability, content integrity, analytics, to show which ones influence or protect each vital? You said, "No, I want you to tell me about security and access control and how the two together can fight off 90% of attacks, if that number is correct. If not, fix it. But please only use alphabetic characters." ChatGPT said, "Security and access control work together like the walls and the gates of a stronghold. Security is the wall. It keeps danger out by hardening the structure itself. It uses firewalls, encryption, and software updates to block known weaknesses. It hides system details, closes open ports, and filters malicious data before it can cause harm. It is the overall discipline that keeps the foundation safe and the code clean. Access control is the gate. It decides who can come inside and what they can touch. It checks identity, verifies requests, and limits how many times one visitor can knock on the door. It uses passwords, keys, permissions, rate limits, and domain rules to keep strangers from wandering into private rooms or stealing resources. When the wall and the gate work together, they stop most hostile traffic. Security filters out what is clearly dangerous, while access control restricts everything else to its proper place and speed. Together, they block the majority of low-level attacks such as brute force, attempts, scraping, hot-linking, spam floods, and data theft. They also blunt many higher-layer floods by cutting off repeated or unauthorized requests before they reach the heart of the site. In a typical environment, these 2 layers can stop about 8 out of 10 common attacks on their own. The remaining threats are complex or large enough to require deeper tools, such as application firewalls or distributed defense networks. But for most small and medium sites, a well-tuned mix of security and access control already prevents the vast majority of real-world abuse. Their power comes from balance. Security hardens everything by default. Access control shapes behavior and limits motion. The result is a system that is both strong and selective, protecting its core while still welcoming genuine visitors. You said, "Now tell me about what type of code provides the security and access control. Tell me about the code, how it is used, and why it works." ChatGPT said, "Security and access control are enforced through a layered collection of code that runs at several points in the request chain. The code works because it intercepts each request before it can reach sensitive data and decides whether to allow or deny it based on clear rules. Server configuration code forms the first layer. In systems like Apache or Nginx, this code lives inside configuration files or directives, such as rewrite rules and access blocks. It tells the web server which addresses or domains can fetch files, which file types to serve, and how many requests are allowed in a short span of time. Because this code runs before any application logic, it can stop harmful traffic early using very few resources. Firewall and rule code is the second layer. Web application firewalls use pattern matching code that compares each request to a library of known attack signatures. The patterns are written in simple expressions that look for unsafe input or commands inside form fields or query strings. When the rule matches the firewall blocks or sanitizes the request. This works because almost all exploitation attempts must send distinctive data that these patterns can detect. Authentication and authorization code lives inside the application. It handles logins, tokens, and permissions. The logic is often written in languages like Python, PHP, or JavaScript using secure frameworks. This code checks the identity of the user, then grants access to only what that identity is allowed to reach. It works because it maintains a verified session token that must match every action request so that no one can borrow another user's authority. Rate limiting code is often implemented through middleware or server modules. It tracks request counts by address or session and pauses or rejects requests that exceed a threshold. The code uses counters stored in memory or small databases. It works because a legitimate user rarely sends hundreds of identical requests in seconds, but automated attacks do. Encryption code protects data while it travels and while it rests. At the server-level, libraries handle secure transport using protocols like transport layer security. In the application-level, code hashes and salts passwords before saving them and encrypts private data before writing it to disk. It works because even if an intruder sees the stored data, it cannot be read without the proper keys. Logging and monitoring code closes the loop. It records every denied attempt and every error so that patterns of abuse can be spotted. This code does not stop attacks directly, but it feeds the defenses with knowledge about what to block next. Together, these forms of code build a complete security and access control fabric. Each part acts on a different step of the request path, and because they overlap, one layer catches what another might miss. The result is a site that quietly inspects every request, allows what is safe, denies what is not, and learns from every encounter. You said, "Are these the concepts that block 90% of attacks?" ChatGPT said, "Yes, those are the core concepts that, when combined and properly configured, block roughly 8 to 9 out of 10 real-world attacks before they ever reach the sensitive parts of a website." Let's restate that clearly in plain alphabetic language. Security and access control depend on specific types of code that work together in layers. Each layer covers a common weakness and removes a large portion of hostile traffic. When all layers run together, they overlap and leave very little open space for an attack to pass through. Server configuration rules stop most automated floods, hotlinking, and direct file access attempts. Firewall and rule code catches dangerous input, such as script injection or command strings. Authentication and authorization. Logic prevents strangers from pretending to be users. Rate limiting code slows or blocks repeated requests that signal a brute force or denial attack. Encryption routines make stolen data unreadable and protect it while traveling. Logging and monitoring code provides the awareness needed to adjust and improve every other layer. Each one removes a percentage of attack attempts. Server and firewall rules usually block about half of them. Rate limiting and authentication stop another large slice. Encryption and logging close off the easy reward for an intruder, making further effort pointless. No single piece of code stops everything, but the combination forms a shield that prevents the great majority of network abuse. The remaining attacks that do succeed are usually complex multi-stage exploits that require deeper analysis or a large network to absorb them. So yes, these are the practical coding concepts that together account for roughly 90% of effective defense in most small to medium website environments.